recording, and then I got to click display, and then I got to make sure it's recording, display, and I can minimize it. If you ever see me forget one of those steps, let me know, because I screwed up last week. Okay. Here's some announcements before we start. So on the problem sets, you need to read carefully, start early, look at the lecture examples, and consult Piazza. If you got a question and you don't see the answer on Piazza, then you ask a question on Piazza. Lots of you did not read carefully, did not start early, did not look at the lecture examples, and did not consult Piazza. And lots of problems that people have on PS1 could have been avoided if everyone had done all those steps. Okay? I don't know. A large number of students, I think, saw the assignment and didn't realize that the first week of class, the second lecture, I did an example, and I said, I have practically done PS1 for you. This is, this shows you how to do everything you need to know to do PS1, how to read from the pop-up dialog, how to format numbers to a particular number of decimal places, how to display the result in a pop-up dialog. The only difference was you had to add a few more pop-up dialogs and do different calculations. But instead of looking at that, people went and Googled up how do you bring up a pop-up dialog, and ended up using J-option pane, which the assignment, if you read carefully, said do not use. Okay? So if you don't have all the lecture examples in your Eclipse workspace right now, you're doing it wrong. Get those examples. They're all available. I'll show you again how to do it. They're available. You should have them so you can consult. The best examples are not the ones you find online. They're the ones I did in class. So take that to heart. Instructure changed something about Canvas recently. They're basically not supporting anything but the very latest and the two latest versions of each browser. And the consequence to that to me was that the CPM is unable to log in anymore, at least on Windows. So as long as you're logged in, you're fine. But if you ever log out of the CPM, you won't be able to log back in until I fix the problem. So I just want to tell you that we're working on it. But also tell you that you don't need the CPM. You can grab everything you need to grab without the CPM. So let me just show you in case that you're having that difficulty. If you go into Eclipse, not Eclipse, what am I doing? If you go into Canvas, right here, you see Files. So click on Files. You'll see Course Files. Click on it. You'll see Assignments, Labs, Lecture Solutions, the same as you see in the CPM. So let's say you want to look at lecture examples. Click on Lectures. And there's a bunch of stuff here you can't see yet because I've got it hidden, but down here at the bottom are all the lecture examples up until today. So you just download the zip file the way you download any other file. Once you get it to your computer, you can import it into Eclipse. The CPM does that automatically for you. So it's a few more steps without the CPM. But you can go find that. You could go look at assignments. There's PS1 and PS2, the only ones that are visible right now, and so on. So you can do that. Now, when you need to know, once you've got the zip file on your computer, you can go to the home page here, click on Resources, and one of these links talks about how to import a project into Eclipse. So you follow those steps to do it. So it's doable. So if you need to, do it. CPM's handy, but it's not absolutely essential. Okay? Here I am. Okay, this morning I made sure that L1 through L3, P1, all the first 2 weeks worth of, I left off one there. The first 2 weeks worth of challenge and participation activities are all graded and recorded on Canvas. So I'll tell you one more time, although I keep getting asked this question. When you do something in the side book, it is not immediately recorded on Canvas. It doesn't happen until I have a script and do it. I typically don't do it but once after it's due. Okay? the TAs enter the grades on the lab are based on on attendance. And so the TAs record those during the labs. And all I did today was put zeros next to everybody's name that didn't go to the lab. So anyway, those are all current and up to date. PS1 will be graded soon. Now, when we grade it, the grades will show up on Canvas, but they'll also be on GradeScope. And the place you ought to go to look at it is on GradeScope, because on GradeScope you'll see not only your grade, but you'll see a breakdown of if you lost any points, why they were deducted. And also on GradeScope, it's possible for for about a week after the grades are released, if you see we made a mistake, you can ask for a regrade there. So if you make a mistake, you can tell us why, what you think the mistake is, and we'll take a second look. But do it on GradeScope. Don't do it by emailing us or posting to Piazza or putting a note on Canvas. God forbid, don't do that last thing, because we just never noticed that at all. Do it through GradeScope. And again, as a reminder, you can miss 3 labs through the semester. There are 15 labs. You can miss 3 of them without penalty. Your lab grade is based on your, it's based on attendance, but we throw out the 3 that you miss if you miss 3. As long as you get, you can miss out on 20% of the participation activity points and still get 100% on participation activities. Same thing for challenge activities. So don't sweat it if there's some challenge activity you can't do. Just skip it. You just have to get 80%. Don't let it ruin your day. And you can submit 4 problem sets up to 1 day late. Okay? You get to choose. So PS2 is due Thursday, but if you want to take a late day, you can submit it on Friday. You don't have to ask, you just do it. Okay? Any questions or problems about anything? Yeah?
I was just curious as to how much or how often there's a disparity between the auto grader and the final grade for the assignment.
Okay, he's asking, how often is there a disparity between the auto grader and the final grader? Okay, the first on GradeScope, the first assignment is tough to grade with test cases. And the reason is you can make a very simple mistake and get no credit. For example, if you use a J-option pane, if you said J-option pane dot show message dialog instead of dialogues dot show message dialog, I think you'd get 3 points. Maybe, yeah, I think that's what you get. Okay, because my script is expecting you to be using, the grading script is expecting you to be using dialogues, not the option. So what I'm going to do is go through the low scores on the auto grader and try to make the grade reflect the severity of the mistake you made, not so you don't lose all the points. So that's.
So just to follow up, if the auto grader gives me full credit, I could expect to get full credit for the.
Yeah, if you get full credit, if you got 60 points, you're going to keep the 60 points. I'm saying that if you got 3 points, you might end up with more because depending on why you got 3 points. Okay, but for PS2, you've got the exact test that the auto grader is using. So there's, if you want full credit, pass all the tests. That's all I can tell you. Any other questions? Okay. So we've been talking about expressions and statements, and you'll recall that an expression is, it can be a literal or variable, or it can be a larger expression that's composed from simpler expressions like literals and variables. So you have a lot of experience with expressions. And an expression has a type and a value. So the questions you ask about an expression are, what is its type, what is its value? Statements, on the other hand, are composed of simpler statements and expressions. And what they do is they control the order in which statements are executed and the order in which expressions are evaluated. So statements do things. Expressions have values. Expression isn't going to do anything without a statement to cause it to be evaluated. And we started out looking at expressions because they're so fundamental. And now we're looking at statements. And we've looked at a few. There's one kind of statement, a variable declaration. So you're familiar with that one. Declare a variable, give it initial value. We've talked about assignments, where you change the value of the variable. Okay, another kind of statement. Method call all by itself with a semicolon after it can be a statement, but only if the method you're calling does something other than return a value. So it makes sense to call show message dialog because then a box pops up. It doesn't make any sense to call map.square root all by itself on a line because it'll return the square root, but what will happen to the square root it returns? Nothing, it's just thrown away. And so sometimes the compiler will, the Eclipse will mark that and say, it's pointless to be doing that. Now, if you said double x equals math.square root 17, then that's fine. In that case, we're talking about a variable declaration. And finally, we've seen return statements. So you've seen that something like return true in a Boolean method would cause the method to end. So return always causes the method to end. And then after the return, you give the value, you give an expression whose value is what you want to return, what you want the method to produce as its result. It's possible also to put a return in a void method, but as you can see, there's no value to return. So what's the point of putting a return in a void method? Yeah?
If you want the method to end early.
Right, if you want the method to end early. So normally a void method just runs, if it starts at the beginning, if it gets to the end, then it automatically returns. But sometimes you want it to return when something else happens. So you can just put a plain old return with no expression after it. It calls a void method to end, to terminate. So those, you're able to do PS1 with these kinds of statements. And for the next few weeks, we're going to be learning about more kinds of statements. And the first one we're going to be learning about are called conditionals, or if statements. And as it says up there, programs would be kind of limited if they couldn't make choices. Okay? So the if statement lets a program make choices. So let me explain what's going on with this if statement here. So if is a keyword, and then else if, and then else. So you see the way it works is when this statement's encountered, so that's a compound statement because it contains simpler statements, this Boolean expression right here is evaluated. Okay? That'll either be true or false. If it's true, these statements are executed, and when we're done executing those statements, we just pick up below the statement, the if statement, and continue along. We ignore the else if and the else. Now, if this is false, we come to the else if, the first else if. Evaluate that Boolean expression. And if that's true, we execute these statements, and then we're done with the big statement. And if we can't find anything that's true, we do what the else says to do. So that's it symbolically. We'll look at examples which will make this make a lot more sense. But that's the syntax of an if statement. And I'll just get this out of the way. Every if statement has to have an if part. You can have any number of else ifs from 0 on up. So you could say if, else if, else if, else if, else if. And then if you want to, you can have an else at the end. That's optional. So the simplest if statement would be just an if with no else ifs or elses or anything. So that's what it looks like. Rather than try to answer questions there, let's just look at some programs that use conditionals. Okay, forgot to make the font big, so just hold on for a second. Okay, so here's a method I want to write, max. It takes in two integers, x and y, and I want it to return the larger of the two. So up here's an example. What should be printed when we execute that statement right there in the main method? So it's going to print the result returned by calling max of 8 and 12. Right, it should print out 12. And there's a math.max method, so we could just use that. But I want to use this to illustrate how a conditional statement works, how an if statement works. So when you write an if, you got to think, okay, I'm making a choice. So the first thing you got to answer is how many choices are there? How many possibilities are there? Okay? So think about the behavior of this method. How many different results can it produce in the end? if you pass it 8 and, or you pass it x and y, what might it return? X or y. So in some circumstances it returns x, in others it returns y. So there are two choices to be made. So the structure is going to look like this. If something is true, we're going to do something. Else, we're going to do something else. So what are the two things we want to do? What are we choosing between? We either got to return x or return y. So sometimes, if the circumstances are right, we'll return x as our answer, and sometimes we'll return y. Now, what needs to be true if we're going to return x? Right. So if x is greater than y, so we need a Boolean expression there that's either true or false. So let's read this. If x is greater than y, we return x, which means that if x is greater than y, it's going to execute that statement. And what's going to be the result of executing that statement? Not the program, he said program ends, the method ends. So the method ends, and x is returned as a result of the method. And if we call it from up here we'll notice that Max returned 12, and it will print it out. And if x is not greater than y, then we're going to skip to the else part and return y as the answer. It's just making a choice of which return statement to execute. So when this method runs, this expression will always be evaluated, but only one of these statements will be executed. It just depends on what the condition says. Okay? So that's about as simple as an if statement gets. Just making a simple choice. You've got to have a Boolean expression that makes the choice for you, true or false. Any questions I could answer about that? Now, I'll warn you, on PS2, I keep hearing from students who apparently have studied if statements in the past. And lots of people are really eager, almost desperate, to use if statements to do PS2. Okay? It just makes it more complicated. There's no need to use if statements or any kind of loop in PS2. And I know that if you're comfortable with ifs, then I can see why you want to use them, but just expand your mind here and learn something new. Do it with, it says in the assignment you'll lose points if you do. So don't use any if statements in PS2. You can use them in PS3. Well, let's test this out. So here's a common question I get. I find that the students, and apparently a lot of the TAs, don't know how to run JShell. So the students keep telling me that the TA couldn't figure it out. All right. Now, if you come up here and run it, launch JShell, then you're getting JShell, but JShell is not going to know anything about this project here. You won't be able to run the code from the project. You'll just be able to, you can do other things, but not that. So what you want to do is go to the project here and right-click on it and launch JShell that way. Okay? So it'll show up down there, and I had a student in my office yesterday that didn't have to type all those enters to get the prompt to show up, but on my computer I do. Now once you're there, if you're curious, you can type /imports. And you can see that JShell automatically imports java.math, java.net, and so on. It also imports CS14. It imports CS14, everything from CS14, CS1410. It's importing all the classes defined here. That's why we can use it. So now we can use it. We can say the name of the class is conditionals. So if I say conditionals .max, so that's the name of the method, max. I say 3 and 7, and it's plural. Okay, so it returns 7. Up arrow will take you back to the last thing you did. So if we change this to like -5, we get 3. Yes?
If they make changes to their code, do they need to close the JShell and open it back up?
Okay. Let's suppose you make changes to the code. It's not going to notice. So if I came up here and let's say I did it wrong. I said return y, return x, which is backwards, and save it. If I come down here, it's still running the old code. So the thing to do is reload. And now if I run that, it should get it wrong. So it reloads the thing. You can, if you want to, you come back up here and reopen JShell. But then, at least on my computer, I had to hit enter 10 times. So reload is the thing to do. Thanks for asking that. Okay? Any other questions? Okay. Let's try a different method. Now I'm going to take the max of 3. Now, actually, this points out something. You notice that I have 2 methods here, both called the same thing. I have one method called max here, another method called max here. So how do I get away with that? In particular, when I call it, how does it know? Yeah?
Because if you were inputting 3 integers, it's going to know not to use the 2 integer one.
Right. It looks at, so what she's saying is it looks at the parameters that you're passing. So if we use it down in JShell and pass 2 ints, it's going to say, okay, is there a max that takes 2 ints, and use it. If we pass 3 ints, it's going to use the one that takes 3 ints. If we try to pass 4, it's going to say, no, I don't know that method. So you can use the same name for 2 different methods as long as the parameters are different. So it can, so they can be told apart. All right, so that's that. We're going to need a conditional here to pick the largest. How many possibilities are there here? How many choices are we having to make? 3. So 3 is going to be if, else if, else. Okay, so let's at least get the structure of this right. So we can say if something is true, I don't know what that something is yet, we're going to do something. Else if something is true, we're going to do something else, do something else. So that's sort of the skeleton of our code. So we're gonna have to decide, when should we return X, when should we return Y, when should we return Z. And those are the 3 things we've got to choose from. So when should we return X? What should we put in the parentheses there that when it's true means we should return X?
If X is greater than Y and X is greater than Z.
Okay, so if X is greater than Y and X is greater than Z, we return X. So you see why it was important to study expressions before we studied statements, because we had to know how to write something like that. Right? We have to know how to write a Boolean expression that could tell us whether X is greater than Y and X is greater than Z. Okay, suppose X is not greater than Y. So we know X is not the biggest number. We know that either X is not greater than Y or X is not greater than Z. But anyway, X isn't the right answer. So what can we check for here in the second case?
Y greater than Z.
Right. Now we just got to choose between Y and Z. We've ruled out X. So we can ignore X. So if Y is greater than Z, we can return Y. And otherwise we return Z. And that gets it. So these if statements are really common in programs, except in PS2 where they're not found at all. But any other kind of program, you find lots of ifs. It's very basic. Basic's the wrong word, very essential. So any questions about that? All right, before I do that, I want to do this. I'm going to make a new method here. I want a method that will tell me whether or not a number is even. So if we pass in 8, I want to get true back. Pass in 13, I want to get false back. Okay? So, got an idea?
Yeah, divide by 2 and if the remainder is 0.
Okay, so if you take the number and, well, if you need to divide it, you need to divide it by 2 and look at the remainder. So if the remainder is 0, you know it's even, right? If you divide 8 by 2 and the remainder is 0, remember integer division is, there's a quotient and a remainder. Divide 8 by 2, you'll get 4 as the quotient, 0 as the remainder. Therefore it's even. If you divide 9, you'll get 4 as the quotient, but 1 is the remainder, so it's false. So it would look like there are two possibilities. If something is true, we're going to return true, else we're going to return false. What is the thing that needs to be true if we're going to return yes, n is even?
N mod 2 equals 0.
Right, so we got to do n mod 2. So the percent sign is mod. That tells us the remainder after dividing by 2. And we got to check and see if that's 0. So if the remainder of n divided by 2 is 0, return true, else return false. I'm going to call this is even 1 because I'm going to write another version. Now, this is a pet peeve of mine. What that is saying that if this expression is true, return true. If it's not, if it's false, return false. Can you think of a simpler way to write that? So let me copy this while you're thinking about that. Suppose this method were on PS2, and I said, you can't use conditionals, you can't use ifs. And people push back and say, you have to use ifs. People have pushed back already this week. Yeah.
Just plug in what you have in the if statement into the return.
Right. So we just do this. Let me just do this here. No if required. Need to call it is even 2. Okay? We're already computing, in the first version, we're computing n mod 2 same as 0. That's either true or false, right? If it's true, n is even. If it's false, n is odd. So just return the value of that expression. There's no need to use the value of that expression to decide whether to return true or false. Just return the value of the expression. It's already the right answer. And that is a lot simpler. Even 2 is simpler than is even 1. So it drives me nuts when I see code that says if some Boolean expression, return true, else return false. Just return the Boolean expression. Now, I did have a back and forth conversation with a student via Piazza. I think it was probably a private conversation. And what the student didn't understand, the student was under the impression that if you need to return a Boolean, you either had to say return true or return false. Didn't realize you could say return n mod 2 same as 0. Okay? So, for what it's worth, I much prefer to see this. So the way it works is, the value of that expression is calculated. It's either true or false, and whatever it is returned. No need to take the long way around. So just beware when you've got a method computing a Boolean, sometimes you just compute it and return it. You don't need a conditional to make that decision for you. Okay? Now, I know people look at that and, you know, anytime people look at Boolean expressions, especially in that context, they seem to get uneasy. It just looks weird. And maybe it's because it's this weird mod operator, or maybe it's because, you know, as I've said before, you're not used to calculating Boolean expressions in math class. But if I said return 2 times n, I don't think that would cause anyone unease. But when I say return that, perhaps. Any questions I could answer? Okay, now here's a weird one. Returns the square root of the absolute value of x. Well, there's a math method that computes the absolute value. But I don't want to use that. I'll let it, we can use the math square root method, but I don't want to use math.as. So, how can we compute the square root of the absolute value of x? Yeah?
Use the math absolute value.
Oh, but I don't want to do that. That's off limits. Yeah.
If it's negative, multiply by -1.
Right. So what we can do is, I think I put this in just so we could have a conditional that only has an if, no else ifs and no else. So if x is less than 0, let's just negate it. So there are a couple ways we could do it. The simplest way is this. Now, that notation you never see, well, you might. You're not going to see something like 2 equals negative 2 in math, right? Remember, equal sign means assignment. So what's that assignment statement doing? Yeah, it's negating x and then storing it back into the variable x. So whatever x contains, say x contains negative 3, it negates it to obtain 3, and then stores it back into x. So after that if statement executes, what does x contain compared to what it contained originally? It contains the absolute value of x. Right? If x was positive to start with, it's still positive. If it was negative to start with, it's now the absolute value. If it was 0 to start with, it's still 0. Now that we have x contains its own absolute value, what do we return? Yeah, we just return math.square root of x. So that's an example. Our previous examples of ifs all had returns in them. Here, we just do something different. We negate a variable when x is less than 0. So ifs. One last example. I don't know if you remember the quadratic formula, but I'll just remind you. It's for finding solution equations of the form ax squared plus bx plus c equals 0. So this method is going to find the real roots of such a quadratic equation. We take in as parameters a, b, and c. And you may remember that one key thing is the discriminant, which is b squared minus 4ac. And I've written an expression that is the discriminant. So I'm computing the discriminant and storing it in a variable called discriminant. And then the way you solve quadratic equation depends on whether that discriminant is 0, negative, or positive. So there's going to be 3 possibilities. If discriminant is greater than 0, let's make it equal to 0 first. Okay? So the whole formula is negative b plus or minus the square root of the discriminant over 2a. So what do we do if the discriminant is 0? What do we want to print out? I had this thing print out instead of return. I'll remind you, the formula is negative b plus or minus the square root of the discriminant, all divided by 2a. So discriminant is 0. What does that reduce to?
Negative b over 2a.
Right, it's negative b divided by 2 times a. Right? That's just the formula. So that deals with a 0 discriminant. What do we do if discriminant is positive? So we got negative b plus or minus the square root of discriminant over 2a. So there are 2 roots, right? So we got 2 things to print out. What's the first thing we got to print out?
Negative b plus.
Sure, negative b plus the square root of the discriminant. And then we got to divide that mess by 2a. Trying to put a paren around it, and it's fighting me. And it's plus or minus, so I'm just going to copy this. And we'll do negative b minus math.square root of the discriminant. So that's good. And the other possibility is that it's negative. And what it says to do up there is to say no roots if it's negative. So I'll do what it says to do. And there's our method. So 3 ways. If the discriminant is 0, we compute and return. We compute and print the single root. If the discriminant is positive, we print both roots. And if the discriminant is negative, which is the only other possibility, we print out no roots, at least no real roots. So here, 3-way choice of what to print in this case. So notice multiple statements in this else if, which is perfectly fine. Okay? Any questions I could answer about that? Yes?
Is there an extra parentheses after the math square root is
As he asked, is there an extra parenthesis, like right here?
No, before that. Before the division.
Right after discriminants.
No, this parenthesis is, I want to group the negative b plus the square root so that that whole thing is divided. The precedence rules, if I didn't put any parentheses in there, things would happen in the wrong order. So I'm forcing the evaluation to happen. I'm forcing the addition to happen before the division. I'm also forcing that multiplication to happen before the division with parentheses. So that 2 times a is in parentheses. And it's possible to make some pretty subtle mistakes with parentheses here that make it print out total garbage. But I practiced before class, so I think it's good. Any other questions? Okay, well, conditionals are great fun. If statements are great fun. But don't use them on PS2. You'll have PS3 to use them on. Let's take a quick break and we'll look at something different. recording. Okay. Okay, now, here's another statement. Called a while statement. And the observation I make at the top there is that programs would not run very long if they could not do repetition. You know, computers can do a couple of a billion operations per second. And so if you wanted to write a program that ran for an hour, you'd have to write billions and billions and billions of assignment statements and conditionals and such to get a program that ran an hour. There has to be, so that's not practical. The reason programs can do things, why simple programs can do complex things is because it's possible to do repetition. That's one thing computers are good at, doing similar things over and over again. And that's what while loops are for. So the syntax of a while loop is it's much simpler than the conditional, much simpler than the if. It's just while, and then a Boolean expression, and then some statements. And the way it works is, if your program's running along and a while statement is encountered, what happens is that expression is evaluated. If it's false, then we just skip on to the next statement and continue on in the method. If it's true, we execute these statements. And then we evaluate the Boolean expression again. If it's still true, we execute the statements. And then we reevaluate the Boolean expression. When that Boolean expression finally becomes false, then we skip past the while loop and continue with what follows. Simple as that. Now, it's possible to write a while loop that runs forever, because if that expression never becomes true, if the expression never becomes false, then the loop won't end. So what does that say about the statements in the body of the while loop? What do the statements have? What relationship do the statements in the body of the while loop have to do with the expression that controls the loop? Yeah.
They have to make sure that they can rename the loop at any point, like through a user input or constant checking of the.
Okay. So to paraphrase what he's saying, those statements have to do something that will eventually cause that expression to become false. Unless you intend the loop to run forever. It turns out there's situations where you do want a loop to run forever. For example, an operating system. You expect it to run until the computer is shut down. So it's basically an infinite loop dealing with things that the user does. So it's easy to look at that and say, this looks simpler than ifs. But it takes, in my experience, it's easy to come to grips pretty quickly with how to work an if statement. It's a lot harder, it turns out, to figure out how to use a while loop. So we'll spend the rest today and next two lectures next week talking about just about while loops, different ways of using them. So let me skip out of here and talk about while loops. Now, I have a way I like to classify loops. And, the terminology I use you won't necessarily find in the Xi book, or you won't find it used exactly the same way online. So you need to pay attention to the words I'm using. And so what I'm about to show you are called accumulation loops. Are called, what's the word say? Enumeration loops. Okay? So an enumeration loop takes some sort of collection of things and does something with each item in the collection. But it doesn't, each thing that's done is independent of every other item in the collection. So I'm going to show you what I mean with a series of examples. It's important to understand enumeration loops because the other kinds of loops that we're going to look at are all based on enumeration loops. And you're not, if you Google, you're going to be totally confused because there are things called enumerations in Java that are completely different things. And they're used in different kinds of loops. This is just terminology I use to be able to talk about simple while loops. So I want to be here. Let's say I want a method where I give it a starting point and its job is to print the next four numbers. So if you call display for ints, and you tell it start at 3, what should this print out? 3, 4, 5, 6, right? Or if you say display for ints of 10, it should say 10, 11, 12, 13. Okay, so that's easy to see how to do that. We just have those print statements. Now, what if I told you I wanted a method called display 100 ints? And same deal, but I want you to print the next 100 ints beginning with start. And we wrote it the same way. What would it look like? Be 100 print statements. All right, and maybe you could do that without making a mistake, and you might be grumbling about it as kind of tedious, but it's doable. Now, what if I ask you to write one like that to print out 1 billion ints? Next billion ints. Now, you wouldn't be very eager to write 1 billion print line statements. If someone really asked me to do that, I would write a program to write the program for me. But fortunately, you don't have to do it that way. So let's skip down here. So here is a method, display ints. Same idea. You give it a start, but instead of it always printing the next 4 ints or 10 ints or 1 billion ints, you tell it how many ints to print. And n has to be, n can't be negative, let's say. So how many ints to print. So that is a job for a while loop. So what I'm about to show you is the prototypical enumeration loop, a kind of while loop, for dealing with ranges of integers. They're doing something to every integer in some range. So what we're going to say is while something is true, each time through the loop we're going to print something out. Okay? So let's think about this. What do we want? We want to print out another number each time through. And we want to, we've got to figure out how to control it. What do you think?
Which of the integers is supposed to be printing? Is it the int start or the int end?
It should print start,
Okay.
and then start plus 1, then start plus 2, all the way up to, it should do that n times.
While n is greater than 0?
Well, while n is, okay, I see what you're going after. Let me go back to my slides here because I want to make sure I stay consistent with them. Okay, this is a enumeration loop on an interval. So you see it right there. So what we're going to do is we're going to have a variable to count through the interval. So he was going to go for a different way that would actually be a little bit simpler. But I'm going to write all the enumeration loops the same. So here's my pattern for enumeration loop on intervals. We're going to declare a variable, our counting variable, so that's I. Its initial value is going to be start. And while start is small enough, we're going to do something with I, namely print it, and then we're going to add one to I. So that's our pattern. And every enumeration loop we write over integers is going to have that same pattern. Now it'll be a little bit different. The condition in the while loop will be different, depending on the parameters. And what we do with I will be different. But the general form will be the same. So let's try this. So what I said was we're going to let int I equals start. And then while I is less than start plus n, we're going to print out I. And what if we ended right there? So we're going to initialize I to start. While I is less than start plus n, we're going to print I. Okay? Let's run it and see. So let's see. Let's run. Here we are. JShell's down here. So let me reload it. And this is enumeration loops. Dot display ints. And let's say we start at 10 and I want to print the first 5 integers. So I want to print 11 through 14. Okay, so we've written an infinite loop. It's printing out 10 over and over again. The loop never ends. And the only way I know to stop it is to kill J shell there. So I do that. So what did I do wrong? Yeah?
You never had the I plus 1.
Right, I need to, that was part of my pattern, I need to add 1 to I. So I is changing. So to count from 10 to 14, we have to add 1 to I each time. Now, when you look at this program, suddenly you're up against something you're not used to. And that is, you cannot look at this program and understand what it does without sort of bringing time into play. I think a lot of students want to look at it and understand just by reading it. You've got to think in your head what happens as a loop runs. You've got to learn to understand what happens as time unfolds. So let's try to work through what's going to happen here if we let start be 10 and we let end be 4. So we're going to go right here. What's it going to do with I? Okay, it's going to store 10 in I, and then it's going to ask, is 10 less than start plus end? So is 10 is I less than 15? Is that true? Yeah. So it's going to print out I. So what gets printed? 10. It adds 1 to I. Now is 11 still is less than 15? Right? So it prints 11, adds 1 to I. I is now 12. Is 12 less than 15? Right? So it prints that. Eventually, I is going to hit 15. It's going to ask, so it'll print 14. It'll add 1 and get 15. Is 15 less than 10 plus 5? It's going to say false, and the loop will end. So if we run that one, so I'm going to have to restart JShell since I killed it. Conditionals dot, not conditionals. Enumeration loops dot display ints. What have I done? All right. Try again. So 10, 5, and it just prints out 10, 11, 12, 13, 14. Now, what would it take to do a billion of them? Oh, I just hit Control S for some reason. Okay? So, why is this program, the reason it takes so long, it's slow, is because printing is slow. If we weren't printing, it would be over already. Okay? So it's no harder to print out 5 than print out a billion. And again, I've got to kill the terminal. Okay? So loops are very powerful. So we went from this, which calls print line, we went from this, which calls print line 4 times, to this, which the number of times it calls it depends on the value of n. So we're counting from I up to start plus, counting from start up to start plus n. And so that's an enumeration loop. Now we're going to see this pattern many times. We're going to adapt it into other kinds of loops. But the key thing is you're always going to be incrementing here. You'll be doing something here depending on what you're trying to accomplish. And your Boolean conditional will look something like that. Now, what if we just wanted to display not just every integer, but every other integer beginning with I? All right, we would just go up by 2 each time. So, you can imagine all kinds of variations on the theme. Let's look at another accumulation, another enumeration loop. So here I've got a string, and I want to display the characters of S. I want to print out each character on a separate line. Okay? So before we were looping through a range of integers. Now I'm looping through a string. So that's another thing we like to do. So let me show you the pattern for that. So that was the typical kind of enumeration loop for ints that we saw before. This is it for strings. So again, we're going to have a counting variable, and it's going to count through, it's going to count from 0, 1, 2, 3, 4, 5 up to the length of the string. And then it's going to do something with the character stored at that location in the string, and then it's going to increment. So let's go try that out. So to display all the characters, we're going to declare I equals 0. And then while I is small enough, which means while I is less than S dot length, we're going to print out what? Right, we print out the character at index I. And then we got to remember to add 1 to I. Now, if you're writing a different kind of enumeration loop for strings, it would look exactly the same. This is the only thing that changes. Just whatever the thing is you want to do with each character, you do. But the framework around it of that loop is the same. And that's really powerful if you believe this, because if I ask you to write an enumeration loop over strings, you just take the prototypical one, paste it into your code, and change one thing about it. Try to write it from scratch, at least at first, you'll tend to get it wrong. So let's try this one out. Okay? So it's just zipping through, generating indexes into the string. 0, 1, 2, 3, 4, 5, up to the largest one, which is 1 less than the length of the string. Prints out each character on its own line. So that's an enumeration loop that can chew through a string, no matter how long it is. Okay? Surely at this point somebody has some question about something.
The while loop you said I is greater than or less than or equal to S dot length.
Not less than or equal to, while I is less than the length of x, yes.
Okay, like if it was equal to that, then out of bounds.
Right, so the problem is if your string has length 10, mine has strength 11. So anyway, let's take my string. My string is length 11. The valid indexes are 0 through 10. 11 is not the position of a character because you start with 0. So if we change the program, so while I is less than or equal to s dot length, you'd be off by 1, and at some point it's going to try to grab the character at index 11 that doesn't exist, and you'll get an error. And it's worth seeing that. So let's come down here and reload. And when I reloaded, it actually reran the method for me. So it reran that, and you'll see that after it printed out hello world, we got an exception. Now, here's the thing. Here's what I've discovered about students when they first see exceptions. They see an exception like this, they go, oh, it crashed, and they do not look any further at the details. There is a wealth of information in this exception report that you can use to figure out what's wrong with your program, and it's going to become important when you start writing loops. So let's look. Let's see what this is telling us. First of all, it tells you what went wrong. There was a string index out of bounds exception. Now, just that term alone, what does that suggest to you that was wrong with your program? Maybe there was a string index out of bounds in your program. Okay? These exceptions usually have nice long names that let you tell exactly what's wrong. So that was bad. And then it even says, if you didn't get that, it says string index out of range, and then it says 11. So it tells you the index that was out of range was 11. So it's telling you that 11 was, it tried to index into the string using 11, and that wasn't a good index. That's a good clue too. Now let's keep looking. What it shows you here is where it happened. So this line here where it says at string Latin, this first one, at, it says it was in the string Latin1.java class at line 47 when it croaked. Is that of interest to you?
Yes.
Well, I don't think it is. You don't really have access to the string Latin1 class. That's built into Java. So it was at line 47 when this happened. But you go down here, what it's telling you here is that it was in the string class in the method char at line 702 of string.java. That's what called the char method in that class. This is called a stack trace. It's showing you what happened. You read it from the bottom up. So what it tells you down here is it says this is like probably somewhere in J shell. Then it says it was at line 82 when the problem happened of enumeration loops.java. That's what you care about. That's your code or my code. So it was at line 82 of enumeration loops.java called char and at line 702 of the string class it called a different char and line 47 is where the problem occurred. But you just care about your class. So you look at that line 82. When we come up here, here's line 82. So it's telling you that that statement was executed, the value of I was 11, and that wasn't a valid index. Suddenly you know exactly what's wrong with the program. But that's not what students do. At least beginning students. What do beginning students do when they see this? Other than go, oh, my program crashed. They put their name on the help queue. And the TA comes over after 20 minutes and says, oh, you had a string index out of bounds exception on line 82 of your code. Okay? Eliminate the middleman. Just learn to read these reports, these stack traces. It tells you what's going on. We'll show you more about how the debugger works. You got to figure this stuff out. But I'm just telling you right now, you can figure out a lot just by looking at the report right there. You don't have to think, oh, death, doom, destruction. Now, when I was learning to program, that's, when the program crashed, it could take the computer with it when it crashed. So the computer would crash. We didn't have these fancy things back in the 20th century, or at least the middle part of the 20th century. Okay. So that's string. Now let's look at another one. We've been looking at scanners. So like you have a problem on PS4, or PS2 rather, where I tell you got a scanner that contains 5 integer tokens, and your job is to add them all up. Okay? So you can write code that gets, it will take you 5 calls to next int to pull the tokens out. Let's write a loop that doesn't care how long the scanner is. It just reads every token out and prints one on a separate line. So an enumeration loop that deals with scanners. Okay? So it's going to be a while loop. And it's going to do something in here. So how do we know when it's time to stop trying to pull tokens out of a scanner? Yeah?
When hasNext returns false.
Okay. So we're going to take our scanner and we're going to ask it, is there a next? Do you have a next token? Is there a next token to be had? If there is not, that'll be false and the loop will end. If it's true, there is another token to be had. So we're going to do this. We're going to get the next token. How do we do that? We'll get the next token. And then we're going to print it out. Token. So the way it works is there a next token? Yes. So we get it, we print it. Is there still a next token? Yes. So we get it, we print it, until finally the answer is no. So when you look at a loop like this, you have to think, okay, that is evaluated, then this, then that is executed. Then this is evaluated, then these are executed. Then this is evaluated. You've got to think about it in that way. Yeah?
So, whenever the variable is initialized and you have the initialized in a loop, does that ever reallocate the namespace, or does it just ignore it?
Okay, that's something that would be better to talk about offline. So, but what he's pointing out here, which I didn't think to point out, was we're inside a set of braces here, and so we're declaring a variable inside the body of the while loop. Could we use that token variable outside the body? Could we refer to token right here? No, there's a scope rule that says I can only refer to token inside those braces. I can't refer outside. So it's called a local variable. It's local to the loop. He was asking a different question about how efficient is this, but I don't care to answer that right now. But we could talk after class. Or actually, yeah, we could do that. Okay? So this will take any scanner of any length and print all the tokens out. Okay? So that's the prototypical enumeration loop for scanners. Something that will empty out a scanner. Now, why doesn't this loop run forever? Where are we doing the equivalent of I gets I plus 1? It's that call to next. Not only does that call to next give you the next token, it removes that token from the scanner. It changes the scanner so that token is gone. So the scanner is now shorter. So it modifies the scanner. So that has double purpose. It reads from the scanner. It also changes the scanner, modifies it. All right, now, so we got these enumeration loops, these patterns. I'm going to show you a different kind of loop called an accumulation loop that's built on these patterns. So let me show you here. I want to return the product of the next n integers beginning with start. Okay, so like if start is 10 and n is 5, I want to return 10 times 11 times 12 times 13 times 14. So this is I call this an accumulation loop because it is taking in this case, a sequence of integers and combining them together. Instead of printing them out individually, it's actually multiplying them all together. So you combine everything in the sequence in some way, so you got one answer to return. So let me show you how to approach this. Let's go to our enumeration loop and just copy it. I'm going to copy the body. That's my prototypical enumeration loop. Now, it's not going to be exactly what we want. It helps that start and end are called the same thing over here. And I'm going to paste it here in product. So we've got that. We don't want to print anymore, but we've got to do something here. So I'll put that to remember. We've got to do something inside the loop to do the accumulation. So here's how you turn an enumeration loop into an accumulation loop. First of all, you declare an accumulation variable. So we're going to calculate something we're going to return. What should we call it? Yeah? Total sounds more like a sum. It's not like total. Really, I would want to call it product, but it's confusing because it's the same as I'm going to call it PROD. And I'm going to start out at 1 for a reason you'll see in a second. So if you have an accumulation loop, you start by declaring what I call the accumulation variable. So this is the accumulation variable. Then when the loop ends, you return the value of the accumulation variable. So every accumulation loop will be like that. You start with a variable that's going to contain the value you're trying to accumulate. You're trying to compute. When you're all done, you return it. And, oh, these are ints, so never mind. And what you've got to do inside the accumulation, what was originally our enumeration loop, is update the product. Update prod. And so what we're going to do is this. So that's an accumulation loop. It's a loop plus the declaration here and the return at the end, in this case. So let's think about what it's doing. We're starting prod as 1, and then we're just doing this typical thing of an enumeration loop. We're starting I out at the start, and then we're continuing as long as I is small enough. Each time through, we make sure to add 1 to I. First time through the loop, what's going to happen here? Prod is initially 1. Let's say start was 10. What's going to happen?
Multiply it, and
It's-
then override it.
So it's going to take prod, which is 1, and multiply it by 10, and get 10, and store that in prod. What's going to happen to the next time through the loop when I is 11?
10 times 11.
Prod will be 10 from before. We'll multiply it by I, which is 11. We'll get 110, and store that into prod. And then when the loop is all done, prod will contain that whole product, which we return and display as the answer. Now, why did I start prod out as 1? Why not 0?
It never bends, it always be 0.
Yeah, if you're multiplying things together, you want to use 1. That's the multiplicative identity. If you're adding things up, you'd use 0. Okay? So let's try out this method here. So I'm going to say accumulation loops dot product, and let's go from 1, and we'll look at the first 10 numbers. Okay? So that's 10 factorial, basically. We get that. Let's see if we can understand what's going on. Each time through the loop, I'm going to print out the current value of prod. So what we're going to see printed out is, each time through the loop, we're going to see what prod is. Before and, why don't we do it before and after? I'm going to just make this a print, and I'm going to so there's going to be one line for each time through the loop. It's going to display the value before the assignment and the value after the assignment. And you can see how it builds up down here. If I reload, we'll do that. Okay, and it reran when I reloaded. So you can see I computed product from 1 to 10. So initially prod was 1, and it multiplied by 1 and it got a 1. Then the next time through it was still 1, it multiplied by 2 and got 2. 6, 24. So you can see that this went 1, 2, 6, 24, 120. That accumulated those products, and this was sort of one step behind along the way. So that 6 is the same as that 6. This 24 is the same as that 24. So you can see, if we do the same thing, but we go 100 steps, well, the number's going to get too big to represent as an int. That's worth seeing as well. It went haywire because ints can only be so big. And this was, it was okay up to this point here, and then things turned negative. Eventually they got so big that it all just became 0, overflowed to 0. So just got to be careful. You can't represent humongous integers with tiny little 32-bit ints. Okay? So there's an accumulation loop on ints. Any questions I could answer about that? Yeah.
So would a double work better for this kind of?
Okay. He asked about using a double, so let's try that. So I'm going to have to call that double, I have to call this double. And I think we're okay. So let's reload it. Okay. So in that case, we didn't, we ended up okay. We ended up with, you don't know the exact answer, but it's something times, it's 9 times 10 to the 157th power. It's a humongous number. We can overflow the doubles as well. Let's do like 1,000. See if we can overflow. Yeah. It overflows to infinity. So, yeah.
Back when you were running these integers and everything went to negative when it got really high, was that two's complement? Is that why it got the negatives?
Yeah. If you understand how integers are represented as 2 complement, it's like your odometer rolling over, but instead of, you get to 1,000,000 miles and it rolls over to 0. When integers roll over, it rolls over to a big integer, a big positive number rolls over to a big negative number for reasons I don't care to go into right now. Let me show you another accumulation loop. Let's do this one here for the scanner. Returns the total length of all the tokens in the scanner. So it needs to, it needs to accumulate a sum of the lengths of all the tokens. So if you're going to write an accumulation loop for scanners, what should you do? What should be your first step? I always encourage students to go find the thing that's most similar to what you're trying to do and use that as a starting point. So we haven't written an accumulation loop, so I'm going to copy this enumeration loop for scanners, the prototypical thing that we wrote. I'll copy it. I will paste it right here. And now let's fix it up. We got to grab the token, but we're not going to print them out anymore. Now, remember, they were given an enumeration loop for strings, for ints. There were three things we had to change. We had to declare an enumeration variable at the top, we had to return it at the bottom, and we had to update it in the loop. Same thing applies here. So let's declare a variable called length, and we'll start at 0. You're always going to want to return length when you're done, because that's what you're trying to compute. And then you just got to update length in the loop. So it's really simple to turn an enumeration loop into an accumulation loop. You just make these three changes I said. So what's the new value of length going to be? Every time we get a new token out of the scanner, we want to update length with the length of that token. So what do we do? What's that? Okay, length equals length plus token.length. So each time through the loop, it's going to grab the next token, it's going to find out the length of the token, it will add it to our current accumulation variable, length, and we'll get an updated value stored there. When we're all done, they've all been added into length and we return it. But again, you've sort of got to be able to model in your head what happens over time. That this is executed, and then this is evaluated, and then these are executed, that's evaluated, these are executed, and so on, until finally there are no tokens left. Then we can return the answer. So what I'm trying to get across to you here is we're going to look at accumulation loops some more. Next week, we're going to look at searching loops and optimization loops. They're all going to be based on enumeration loops. And there's almost a recipe. There's a little bit of creativity required, but not as much as we required if you did all these from scratch. So where is the, given that I copied the enumeration loop, what's the creative part of this accumulation loop? I mean, we know we have to declare an accumulation variable. How do we know we have to declare it of type int? Well, that's what we're computing, an int. We know we're going to return its value right there. That's all mechanical so far. So where's the creativity? It's just that. The rest is boilerplate, if you'll trust me. You just got to figure out what kind of loop you're writing. Like if I ask you to write another accumulation loop using scanners, copy that one and change the accumulation variables. You would copy this and just change this, this, and this, depending on what it is you're trying to do. We will pick up with this on Monday.